Hello, everybody. Thank you all for joining us today. My name is Keith Widmeyer. I'm going to be moderating these sessions. Really appreciate everybody's time. And just to keep us on track, I'm first going to stay away from the speakers, but also want to introduce our first presenter. This is Dr. Sarkar, who's going to be going through at the intersection of MXR, advanced visualization, and healthcare delivery.
Thank you. Can you all hear me? Yeah, thank you for that. Yeah. I'll take it. The warm introduction. It's just really exciting to be here. My first vMed was 2019, so 5 years ago, and it's just incredible how this field has evolved, how this conference has evolved, and to be able to still be participating. And thank you. I just looked at the schedule. Yeah, there's some interesting things going on in the other presentations, so I appreciate you all being here. So I'm coming in from New Orleans, and I'm a neuro rehab doc. I spent some time as a clinical informaticist, but I'm going to talk about the fun stuff that we do at Oshler's Biodesign Lab, and going to cover very briefly, and not going to do it justice, the biodesign process and how that's informed our work in advanced visualization, and then dive a little deep about some research that we're doing regarding advanced visualization, and hopefully have some time for discussion. So is anyone familiar with the biodesign process or has heard of it? Oh, okay, great. So it started up the road in a little place called Stanford about 25 years ago. And the mission was to create biomedical technology innovation leaders. Broad mandate, but the impetus was, hey, we have this academic center, not just with a hospital, but with law schools, business schools. We also happen to be adjacent to this hotbed of entrepreneurism and venture capital in Sand Hill Road. Why not take some of these shower thoughts these amazing clinicians are having and scale them so not just people at Stanford could benefit? And so there's a couple of points. I'm not going to, again, do it justice, but there's a whole textbook, there's a whole fellowship you could do. But one of the things about biodesign was that it is interdisciplinary. Much like this conference, it's not just about physicians, it's about clinicians of all stripes, it's about technologists, it's about engineers, it's about legal people, all getting together to really take an insight and be able to deliver it and integrate it into healthcare delivery. And then it's a process too, right? Oh, we're going to train leaders in biomedical technology innovation. That sounds great, but how? And I'm not going to unpack all of that, but one of the things, and the foremost parts of that step, is being solution agnostic. And philosophically, that seems simple, really understanding the need. But particularly for people like us, engineers, scientists, clinicians, it's hard to reduce to practice. We see problems, we have limited time, limited resources, we triage and solve them and move on to the next. And this framework really emphasizes taking the time up front to almost dogmatically understand your need. And then you go to the solutions, the prototyping, understanding compliance and regulatory. Arguably healthcare is the most regulated component of our, and rightfully so, of our economy. And if we're going to be serious about developing innovations, we have to take things like the FDA very seriously. And this field is really doing that with the involvement of the FDA. And then sustainability. And biodesign, traditionally, it's like, oh, what's the next billion-dollar company? And I can declare it here. We have no intention of creating a billion-dollar company, but also, there's no mission without a margin. You have to be sustainable, whether that's understanding CMS and reimbursement, grants, philanthropy. If there isn't a modicum of sustainability, then there is nothing. And then defensibility. Canonically, biodesign started really focused on traditional medical device. And so a lot of this defensibility was around intellectual property, patents, freedom to operate. I'm not an expert about that, but it is important. But in this new age of digital medicine, and particularly in medical extended reality, there's 1,000 applications that say they can do X, Y, and Z, but very few of them have gone through the effort and the rigor to show that. And I think that's something that's unique about the people that are attending this conference, that we're the vanguard. We have to embrace the work that's necessary to validate the things that we're developing. And then lastly, this idea of human-centered design. And for us, reducing that to practice means clinical integration. How do you take these wonderful point technologies and then actually get them to plant and flourish in what is oftentimes Byzantine, Baroque healthcare systems and healthcare delivery? That, is also part of the work that's not necessarily obvious. In the genesis of our lab, the need that we were really focusing on was advanced visualization or medical imaging. And so, this is a rhetorical question. Does anyone know what they're looking at? Any neuroscientists, neurologists, neurosurgeons? Good. Well, it proves my point. This is a group of very highly educated, engaged individuals have no idea what they're looking at. And God forbid this was your scan or someone you loved. How frightening would that be? When someone with a scalpel or a laser wants to go in and do something to you. And so there's a reason why it takes 10 years of post-collegiate graduate training to become a board-certified neurologist, a radiologist. Interpreting 2D planes and having insights is difficult. So that's part of the need. And the other is, I don't know if I'm a neuro rehab doc, so I'm a cognitive neuroscientist by day, and so I'm in awe of our nervous system. I love how the Dr. Spiegel brings that into MXR. And specifically our visual system. We are exquisitely and eloquently designed to consume three-dimensional information. That's why this little simple gesture is such a profound information processing tool. And so understanding a little bit about the need, the information and symmetry from 2D medical images, our innate capacity to intuitively understand three-dimensional information. All right, now let's talk about the fun stuff. Most of us are familiar with these terms. A lot of the places where I give a talk like this, they still don't. So there's virtual reality, augmented reality, mixed reality, spatial computing, and the convergence of that with healthcare is why we're here, this new field of medical extended reality. And I'll put in a couple of plugs that you've heard and will continue to hear. I'm involved in some of these things. The AMXRA, about a year old, maybe a little bit older. Inflection Point, we have a professional organization. The Journal of Medical Extended Reality, first edition, peer-reviewed. Go get it, go contribute, go do the research, get involved. That's what it's going to take to move this field into the next stage. And another technology that may not be as familiar to this group is additive manufacturing, colloquially called 3D printing, where you take a variety of methods and materials, lay one layer on top of another to create a physical 3D model. And this is a graphic of our workflow. And I'm not going to unpack all of it, but I do, for the sake of clinical integration, discuss a few points of this. So we take routine clinical imaging, and what that means is we're not asking our clinical end users to order some new kind of imaging that they're not familiar or comfortable with. We're not asking our radiology techs to do a new protocol or that's going to take time and effort. We're definitely not in these lean times asking our administrative partners to go purchase some fancy piece of equipment. We're taking medical imaging data sets that are procured through routine clinical care and transforming those into advanced visualization models. And then a couple of informatics. I'm a clinical informaticist partly. Informatics innovation. So I live, sometimes ambivalently so, in the electronic medical record. For us, it's Epic and maybe Cerner or something else for you all. But that's where our clinical end users live. And so the early days, sometimes it was an email. Oftentimes it was just a holler down the lab or the hallway, hey, Sarkar, can you make a model for this or that? But over the last 5 years, we've created an Epic order set that allows our clinical end users and their staff to order the images that they need, the routine images, as well as the models that we can create. And then on the imaging informatics side, so when I first came to vMed, again, that's not that long ago, right? 2019. The rub of creating these models was finding where the images were, and then burning CDs and getting them to the people that needed to make models. And now with enterprise imaging and not PACS, but vendor-neutral archives, now we can bring these images to our segmenters and create all these different models with AR, VR, 3D printing. But most commonly, through a web-based viewer that we've developed. Because again, meeting our clinical end users, they need these insights. They want these aha moments, but they may not have time to wait for a 3D printed model or even go down the hallway to put on a VR headset. And so we've created this 3D viewer. And this need doesn't respect clinical boundaries. We do a lot of work in a lot of different specialties, but the bulk of our work is in the neurosciences. And just like the neurosciences has subspecialized, so as our service line. So we do a lot of work in spine, in epilepsy surgery management and planning, as well as intracranial. But our most prolific users are vascular. And so aneurysms and something called arteriovenous malformation. So that movie that we saw, those are models of that original source imaging. On the left is a physical model, and on the right is a 3D digital model. And I'm going to put another plug in for the Masters in Health Delivery side. So Ochsner's, like Cedars, a clinical operation. Research is part of the mission, but the clinical operations are the substrate. And we wanted to really understand and in a rigorous way how we're having an impact. In the master's program, there's a couple of people in here that have helped me along the way, allowed us to design a study to research that. And so we looked at a population of neurovascular clinicians. We used our 3D viewer, and we wanted to compare across experience levels from medical students to staff, and how useful was seeing things in 3D. So what we did, we chose 10 models that we had created randomly, and then sent out a survey that would have that movie like the one you saw. It would have a 3D model like you saw a screenshot of. It'd have the actual neuroradiographic report, and then a survey that was grounded in the literature, asking how complex did you find this? How helpful did you find this model? And then yes, no. Did you see things in 3D that you did it in 2D? And would that have changed your diagnosis or your therapy? So we recruited 18 clinicians and categorize them by experience, self-report. How many of these complicated things have you managed? 1 to 10, you're a novice. 10 to 100, medium experience. And then more than 100, you're an expert. And my hypothesis, I'll own this, was those would be inversely related. The least experienced people would find these 3D models the most useful. And we plotted it. Lo and behold, you just visually inspecting it, it looks like the most experienced individuals found this the most useful, and then with some help, with some statistical wizardry, we were able to actually show that magical P level is less than 0 or 0.05, that there is actually a significant difference in reported utility. And some post hoc analysis, it's actually the most experienced individuals that had the most insight. And has anyone heard of the Dunning-Kruger effect? It's this cognitive bias where people, like my twin 6-year-old kids, they have a lot more confidence in their ability than they actually have ability. And I think this is something, it may play a role in our findings. And so that, engenders some more questions, like how is this really impacting staff? So a little less than 50% of the time, this is staff, these are the experts, are seeing things, normal and abnormal anatomy, in 3D that they wouldn't in 2D. And part of me was aghast. I'm like, these are the people that are cutting on people. How are they not seeing all of this? But then also, that cognitive neuroscience can see we are meant to consume three-dimensional information. Of course they're seeing things in 3D that they wouldn't in 2D. And this wasn't a validated instrument. It was grounded in the literature. And these are not only my colleagues, they're my friends. We go get beers, the kids go to school. Are they just telling me what I want to hear? And we had a trace of validity. This doesn't change their diagnosis that often, less than 15% of the time. When I saw that movie, I knew what I was looking at. I didn't know what to do about it other than send it to one of my colleagues. But it wouldn't have changed my diagnosis. But a little less than 50% of the time, in a hypothetical situation, the 3D viewer would have changed the therapeutic approach. So deliverables, we have a digital infrastructure to create and assess and replicate these kinds of studies. In a diverse cohort of clinicians, we showed substantial utility, and staff-level physicians, we showed, quantified, they were able to have anatomical and therapeutic insights that were not conventionally appreciated. So I think I'm at time, so I will stop, and I want to just thank my team. And then if you have a phone, you should be able to use that QR code to scan and create an AR version of that model. Then thank you.
Just wanted to see if anybody had any questions.
What do you use for, you mentioned epilepsy, that you utilize these models for epilepsy. How so, and what does that look like?
Oh, great question. I think what's something unique about our epilepsy, a little prologue, not too much. Seizures, epilepsy is a disorder of seizures, and surgery is a very effective treatment, underutilized for a variety of different issues. And what our models do is combine electrophysiological data with anatomical data. And so that's a little bit unique for the epilepsy. And I will say, because we talked about biodesign, there's a sustainability model behind that as well. There's actually a billable code when you do that kind of image processing. And that has been a part of the reason why we've been sustainable within the neurosciences. Does that answer?
Yeah, no, thank you. I'll pull you off mine earlier.
Great.
Excellent. Thank you. A quick question, just a little bit more about the mechanics and the workflow to implement a solution like this in a healthcare institution, of being able to create those 3D models for the work that is being done, and be able to convert the diagnostic to the 3D model that's virtual in the headset. So do you have any sense of what kind of process and workflow is required and labor is required to make that happen in an institution? Because we would love to do it.
Yeah, and a lot of negative learning. So what took us 10 years shouldn't take you in this day and age 10 years to replicate. We talk about generative AI. Machine learning has also really helped us. So initially, this was we created artisanal models, is like what we would say. It took a BME, highly sophisticated, a decent amount of time to create these models. We've now trained and deployed machine learning models. AI is not replacing humans, at least not anytime soon, but AI plus human is going to replace human, and for us, it's also requalifying the human resource. So maybe you don't need a biomedical engineer to do all the segmentation if you have ML, and so that has been a part of our sustainability. We're not Mayo Clinic. We can't hire a football team of biomedical engineers. There's a lot of attrition. We can barely retain the biomedical engineers that we have. So using those kinds of tools and technologies, and then meeting your end user where they are, and addressing needs that are valuable. I'm not a spine surgeon. Why was spine the first place we weren't? Because that's what keeps the lights on. Thank you. Great question.
Any other questions? I know I have a bunch, but I will definitely catch up offline. I love seeing simulation outside of the typical training and just going through and seeing all the different possibilities. So thank you so much.
Thank you.
All right, ready for our next presenter?